Hello again. In this video, we're going to go over a very important integration technique known as substitution. Okay, so let's look at this example. Now, in this example, we want to find this indefinite integral. In other words, we want to find an antiderivative of this function. It's not obvious as to what that function would be. So one thing you could do is FOIL this out 9 times and then distribute the x to the fourth to each of the terms in that polynomial. And then you could find this antiderivative by finding the antiderivative of each of the terms and then adding them up, adding up those antiderivatives. Of course, the problem with doing it that way is you would have to FOIL this out 9 times, which is very arduous. So there's an alternative way of finding it, and that's using this method called substitution. So here's the idea behind substitution. Right now, this indefinite integral is written in terms of x, right? The variable of integration here is x. And what we're going to attempt to do is change the variable of integration to another variable called u, with the hopes of being able to find the antiderivative of that function written in terms of u. Okay, so here's what we're going to do. We're going to let u be the inner function in this composition, and that's generally what you're going to do when you make your substitution. So this is our inner function, right, in this composition right here. So I'm going to let that be u. Okay, then we're going to take the derivative on both sides of this equation with respect to x. And of course, that's going to give us du dx on the left. And then on the right-hand side, the derivative of this with respect to x, of course, is just 5x to the fourth. And then we're going to solve for this dx here. Now remember, dx is the differential x, and du is the differential du. And here we're just dividing those two differentials, right? So this can be thought of as a division sign. And so we're going to actually solve for dx here. So the first thing I'm going to do is multiply the dx to the other side. And then we'll divide by 5x to the fourth so that we can solve for this dx. Okay, and then once you've done that, we're going to take both of these equations, right, this top one and this bottom one, and we're going to substitute it into this original indefinite integral. Okay, so this piece right here is u, so that's going to become u to the ninth. And then the dx is du over 5x to the fourth. And of course, we still have this x to the fourth that we didn't substitute for. Okay, so now our indefinite integral would look like this. Now notice the order in which this is multiplication, right? So the order in which you multiply doesn't matter. This is division, and the order in which you divide doesn't matter. You can rearrange these in any order you want. So there's no reason you can't move this x to the fourth up here and divide x to fourth by x to the fourth first. So I'm just going to write it like this. In fact, I'll move the 5 over here as well. So I'm just rearranging the order in which I multiply and divide, and that's perfectly fine. Now keep in mind, there's still this du here, right? The du is going to be over 1. The 5x to the fourth, though, I moved over here. Okay, and that clearly shows that x to the fourth cancels out, leaving you with 1/5. And 1/5 is a constant, so you can pull that outside this antiderivative operator. And that's going to leave you with u to the ninth du. And now notice that you've changed this to a new variable, right? This is a variable of integration was x, and now it's the variable of integration is u. Now we haven't found the antiderivative yet, but we have converted this indefinite integral into a function that we do know the antiderivative of. U to the ninth, the antiderivative of it is u to the 10th over 10, right? Just using the power rule. So now let's find that antiderivative, right? It's u to the 10th over 10 times 1/5 plus some constant c. So the point of this substitution is to convert this indefinite integral that we would have some difficulty finding into a new indefinite integral in terms of u that's much easier to find. So in this case, this is much easier to find. You just have to apply the power rule. Much easier than this original function. Okay, now just remember, you have to substitute back in for the u, right? We converted this to a variable u so that it would be easier to integrate this function. And after you've integrated it, right, this is the integral, then make sure you go back and substitute for u. So u is really x to the 5th plus 6. So this is really x to the 5th plus 6 to the 10th power, all over 50. 5 times 10 plus some constant. Okay, and so that's the antiderivative of this function here. Or it's the family of antiderivatives of this function here. Now, if you want to double check that, you could just take the derivative of this and make sure that it goes back to this function. So let's just do that real quick. Let's see what the derivative of this would be. Of course, the derivative of the constant would be 0, so I'm just going to find the derivative of this piece. Now, to find this derivative, you can pull the 1 over 50 out, since it's a constant. But then you're going to have to use the chain rule to find the derivative of this, because that's a composition of two functions. Okay, so the outer derivative, you'd pull the 10 down and subtract 1 from this exponent. So that would be your outer derivative. And then the inner derivative would be 5x to the 4th. Okay, so the order in which you multiply doesn't matter. Notice you get 50 over 50, so those cancel out. You're left with an x to the 4th, and then times x to the 5th plus 6 to the 9th power, which is the function that we had here. Okay, so this is the antiderivative, or the family of antiderivatives for this original function here. Okay, so that's how we use substitution to find an indefinite integral that's sort of complicated in this case. Now, keep in mind, substitution doesn't always work. It is going to take some practice for you to sort of recognize when you can use it. Even then, if you kind of recognize that you need to use it, it does take a little bit of practice as to try to determine what u should be, because you have to pick the correct u in order for it to work. And my suggestion is to try, at least initially, let u be the inner part of the composition of some functions. So this is a composition of two functions. I just let it be the inner piece here. Okay, but as you build up more experience, you'll begin to see when substitution is a viable option and what you would use to let u or have u be in your substitution that would make it work. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.